Okay, so as we all know, AP Calculus AB is just the easier version of BC, and we should be aiming at finishing this kind of question in under like 10 minutes because it is frankly speaking really straightforward. But I'm talking, so this video is probably going to be like 15 minutes long. But anyways, it is really straightforward. But let's just finish this because why not? So A is well, okay, you know what? Very easy. Let's find. Oops, excuse me. There. Dy dx x equals 2 and y equals 4 is just 3 plus 4 times 4, negative 2 times 2, which is negative 4 over 19. So we could say y equals negative 14 x plus c, which means we could say 4 equals negative 14 times 2 plus c, which implies c is just 4 plus 8 over 19, so that's 78 plus 76 plus 8, so that is 84, which implies y equals negative 4 over 19x plus 84 over 19, and let's put in x equals 3 in there to do approximations. This is just 84 minus 12. So this is the y coordinate approximation required. That's part A. I think that was like 2 to 3 minutes. Part B, all we need to do is to see if y equals 1 intersects the curve at one point. So we have x squared plus 3 times 1 plus 2 times 1 squared equals 48, which implies x equals positive or negative root 43, which implies y equals 1 is not a tangent to the curve. And then part C, we need to find if the line tangent to the curve at that point given is vertical. So we have to check if the tangent has slope positive or negative infinity, which means let's sub in x as root 48 and y as 0 into that, which is very happily given 8, which means root 48 is just 4 roots 3, which means we have this, which is not positive or negative infinity, so that implies line tangent at root 48 0 is not vertical. And then part D, we have something entirely new. So we need to find dx dt given that curve, and then we have dy dt at 4 2. So let's do some implicit differentiation really quickly. So obviously 3y squared dy dx plus 2x dy dx plus 2y is equal to 0, not 24. That was quite embarrassing. So we have dy dx as 3y squared plus 2x at the bottom of negative 2y. And then obviously we will need dy dx at x equals 4 and y equals 2. So we have negative 2 to 3 times 2 squared plus 2 times 4. And that is negative 4 over 12 plus 8, which is 20. So that is just negative 1 over 5, I think. Is that 0.42 exactly? And then yeah, the calculations are not wrong, so let's move on. So dy dt is dy dx dt which implies dx dt is equal to dy dt, dx dy, and then dx dt at x equals 4 and y equals 2 is equal to dy dt at that point, which is negative 2, and then dx dy at that point is negative 1 over 5 to the power of negative 1, which is 10, which implies x coordinate of x coordinate of what? I can't remember. Of particles' position is increasing at 10 units per second. And that's it for this question.